Hello everyone, myself Vibhu. In this video, I'm going to discuss about work energy theorem. This is one of the most important topic I have taken from the 11th classes, which will be appear for 3 marks. So we'll solve this step by step. Okay, so initially, let me consider a body of mass m, okay, which is moving with a certain velocity u. Okay, so the body is having the mass m and is moving with a velocity u. U stands for initial velocity. It is moving with a velocity called as u. And now what will happen? It is moving. Now a force is acting on the body. Okay, now what will happen? A force will act on this body. When the force started acting on the body, I mean same body only. Okay, let me say that. So force F is acting on the body and the body is having the mass M and whose velocity will be changes to V. Initially, it was moving with the velocity U, and on the way, there is a force will act on the body, on the same body, and the displacement from here to here is, I can take it as S. Okay, initially the body was at A and it was moving with velocity u, and the body is now moving at B with a velocity V, where the force F is acted on the body. All right. Now, what is happening now? Definitely, when the force acted on the body, there is a change in the velocity. Now, what I can write is here by using kinematic equation. V square minus U square equals 2AS. Okay. So let me call this as a equation number 1. Now I can solve this further as A equals V square minus U square divided by 2S. As I said that there is a force acting on the body is force F equals ma. That is taken from the Newton's second laws of motion. We'll call this as the equation number 2 and we'll call this as the equation number 3. Now what we can do is now put equation 2 in 3. So now what will happen? F equals m into, what is a here? A is the acceleration. Acceleration is taken as v square minus u square divided by 2s. So now what I will do is v square minus u square divided by 2s. As I said, there is a body which is acted by the force and it was at A, and after applying the further force, it is moved to the point B and it is still in the motion, right? So we have applied the force and there is a displacement also. Correct? Then I can say that there is a work done. Then from the definition of work, we'll call it as a fourth equation. W equals Fs. I'll call it as a fifth equation. So there is a work done, right? So now put equation 4 in 5. So we know that W equals what? F into S. But what is F here? M V square minus U square divided by 2S into S, right? So now what will happen? Where S and S will get cancelled here. Now work done W equals, okay, M into V square minus U square divided by 2. Right, now further what I can write is W equals 1 by 2 m, I'll take 2 outside here. So 1 by 2 m V square minus U square. So further I can write it as half mv square minus half mu square. So again, it looks like, half mv square minus half mu square. V is the final velocity and u is the initial velocity. So now I can finally write it as W equals half mv square minus half mu square. Half mv square is the kinetic energy. Then I can say that the final kinetic energy minus initial kinetic energy, right? So then work can be defined as change in the kinetic energy, right? So W equals what? Change in kinetic energy, because the body was moving with some velocity. After applying the force, its velocity changes. Then it is said it as kinetic energy here. So final kinetic energy and minus initial kinetic energy will be equal to the work done, right? Then work energy theorem can be stated as work done by the net force, means total force, in displacing a body is equal to change in its kinetic energy. This is the statement for work energy theorem. Again, I'm saying that work done by the total force in displacing a body is equal to what? Change in its kinetic energy. So same thing I have put into the statement here. So hope this is clear now. So work energy theorem is said to be change in kinetic energy. Hope this video is clear. Okay. So this concept is definitely clear for you guys. So if you really like this, kindly share with your friends and other groups. So let them learn. And if you have any doubt, kindly post your feedback in the comment section. Thanks for watching. If you are not subscribed, kindly subscribe this video. Thank you very much. All the best.